So it does not matter which box you write in, but save the really large one for when we get to the trig, because there's 6 trig functions, so you're going to need more space for that. Otherwise, it's not like any of these has to go in a certain box, right? We're going to start with the power rule. Now we're going to write dx for each of these. That's instructions that mean take a derivative with respect to x. That's what that means. Like instructions telling you take a derivative. Not to be confused with dy dx, which is a derivative of y with respect to x. I know that's just instructions that mean take a derivative. So if you're taking the derivative of x to the nth, so power rule is for x to the nth. So like x to the 5th, x to the 7th, x to the millionth. So you're going to take the power down, write it out front. So like that n comes down. And then what do you do to the power for the power rule? Subtract 1. It's going to lower by 1. Last unit, when we graphed the derivatives, we talked about that. You go down a degree when you take a derivative. So like cubic became quadratic, quadratic became linear, so on and so forth. Okay. So go to the notes and we will try a few of those. We're doing 4 rules today. We'll just do them one at a time. All right, so the first one, f prime of x equals, and what is that going to give us? 12x cubed, perfect, minus 12x. Now we won't simplify every single one of these because, you know, some of them get, like, they turn into a pretty big disaster. But it seems like something that we could factor or simplify. I'd like for us to do that. What could we factor out of both of those? 12x. And when you take out a 12x, let's just do this mentally. What's going to be left? X squared minus 1, which will actually also split. X squared minus 1 will, it's a difference of squares. It'll split into x. Good, x plus 1, x minus 1. People tend to forget about 1. Like, I totally get it. It's because 1 times 1 is 1, like 1 squared is 1. All right, let's go through the square root. I will only do this once. After that, I'm going to be like, you probably just need to know this one. It's x, let me ask you guys, it's x to what power? Is 1/2, good. So that means x to the 1/2. So when we go to do the power rule, you would bring the 1/2 down, and then you have to subtract what? So unfortunately, you end up with a negative. 1/2 minus 1 is -1/2. Now you don't want to leave a negative exponent in there, so we are going to have to fix that. So I would put 1 in the numerator, draw a fraction bar. You're going to have this 2 down here. That's for the 1/2. The negative exponent reciprocates it. So that's now going to go in the denominator as well. The negative exponent just goes down to the denominator. And x to the 1/2 means square root. So here's what I always tell everybody. You would do well just to know that one. So you don't have to go through the halves and the negative halves and flipping it every time. Derivative of square root is 1/2 square root. Like it will be to your benefit to just know that one. Is that making sense? 1/2 square root, just know that one, because otherwise you have to deal with all of that. All right, this one's also going to have a negative exponent. You can rewrite this as what? Not doing the derivative yet, just rewriting it. Perfect. 3x to the -5th, then do the power rule, and then fix the negative exponent at the end. So power rule, you're going to bring the -5 down. It'll be -15. Careful with the negatives. You have to subtract 1, so it's going to like go more negative. So what will your new power be? -6, and then just fix that. So it'll be -15 over x to the 6. Good. And I say this all the time. What messes people up in calculus most is the algebra. It is, because you're just expected to remember every single algebraic rule ever. Got that? And all the trigonometry. Just know everything you've ever learned ever in a math class is essentially what calculus is. So it's hard. How about number 4? It's just 16/23. 0, good. The derivative of any constant is going to be 0. And constant just means lack of a variable. So there's no variable. That's power rule, not much to it. Just be careful with fraction and negative exponents. Ready for the next one? You're like, not really, but if you make us. All right, product rule. So what does the word product mean? Yeah, multiply, right? Like you're multiplying two functions together. So we're going to do the derivative of f times g. Don't get hung up on one being called f and one being called g, because on the AP exam, they could call them q and r. They often do things like that. Like the letter of the alphabet does not matter. So in your brain, I want you to think of them as the first one and the second one. Because if you get hung up on f and g, it's going to mess you up later. Okay, so think of them as the first one and the second one. It is the first function times derivative of the second, and I'm just going to ask, and then remember what comes next. First times derivative of the second. Perfect. And because it doesn't matter what order you add in, if you want to do this, because some people just prefer to do it the other way, that means the exact same thing. Okay, I'm always going to do it this way because I just start with the first one. But if your preference is the other way around, like you do you. Okay. So let's try a few of these. The hardest part is knowing when you need what rule. The reason you need a product rule for this is because do you see how you have two separate sets of parentheses? Like this is the first thing and this is the second thing. Like identifying what rule you need is oftentimes like the hardest part of it. Okay. So derivative equals, we're going to take the first thing, just copy down that first set of parentheses. So it's just the first thing. Times derivative of the second thing. Oh, we have a negative there, so let's be careful. What's our derivative of the x to the negative 2? Good. Oh, you guys have got it. Plus, and then 5. Awesome. So first times derivative of the second. We will fix that negative exponent in the next step. Plus the second thing, so just, write it down. Times derivative of the first. So that will be 3x squared plus 7. I just want to fix the negative exponents. You can erase and just fix it if you don't want to write the whole thing over again. I am going to write the whole thing over again because when I take a picture of this and post it, I want it to be nice and neat for you. But if you want to just like erase these and fix it, you can totally do that. But let's just fix the negative exponents. So this would be negative 2 over x cubed. And then I think there was another one. How would I rewrite this one? Perfect. 1 over x squared. I just like to go through that because negatives are just such a commonly missed thing. I feel like you can't talk about them enough. All right, so let's see. The first thing, so 2x to the 7th plus 4 times the derivative of the second thing. So what'd you get? 2x minus 3, perfect. Plus the second thing times derivative of the first. So 14x to the 6th, and that's it. I'm not going to make you do this right now, but just to check. If I made you distribute all this to each other and combine like terms, could you do that? Like if I made you do that, you would just distribute this through there, distribute the 4, distribute the 14x to the 6th, you'd end up with something this long. Because they do that on the AP exam, they'll like simplify it the whole way down and you have to do that. Okay. Now this one, you want to rewrite that 4th root of x as x to the 1/4. You can't use a power rule unless there's a power. It's like with the square root, we wrote it as x to the 1/2. Just make a little note, it's x to the 1/4. Okay, so here we go. First, so x cubed plus 2x times derivative of the second. So you would bring the 1/4 down and you have to subtract 1. So hey guys, a fourth minus 1. Negative 3/4. Fractions are fun. And then minus 1, so that's done. Derivative of 1 is just 0. Plus the second thing, now I'm going to write it with the fourth root. The idea is you want to write it with the root. We just had to deal with the power for that in order to get through the derivative. So fourth root of x minus 1, and then derivative of the first function, 3x squared plus 2. I, again, am going to rewrite the whole thing because when I take a picture of this and post it, I want it to be nice and neat for you. If you want to just erase this one, then that's fine. We are just going to fix that negative exponent. So I usually just draw a fraction bar to start with, and then you can decide what goes upstairs and what goes downstairs. So we've got that 1/4. The x is going to go down to the denominator because of the negative. And you have to rewrite it as a root. Listen, if you start with a fourth root, your answer is going to be a fourth root. Taking a derivative doesn't change that. It can't magically change into a different root. Okay, so if you get confused about which number goes where, because I know everybody's like, oh, I know it's one way or else it's the other. It down here, because it's negative, it's going to be a fourth root of x to the third. Okay, so again, if you forget which number, that got really small, let me write that a little better. If you forget which number goes where, just remember, the root has to be whatever kind of root you started with. It can't change, okay? And then I'll just rewrite this. I just want it to be pretty for you when I post it online in case you want to look at it later. All right, we'll do a 3-minute break and then we'll do the next page. Okay, so go back to your little organizer here. We're gonna put quotient rule. So product means you're multiplying, quotient is for dividing. So again, half the battle is figuring out which rule you need. So quotient rule is if you've got a fraction in there. So again, ddx is instructions that mean take a derivative. So it means take a derivative of one function divided by another. And again, don't get hung up on f and g. In your brain, you want to think of them as the top function and the bottom function, or the numerator and the denominator is usually what I say. Because again, on the AP exam, they could call them whatever letters they want. And if you're all hung up on f and g, then it's going to mess you up. So think of them as the numerator and the denominator. This one is weird. I heard you guys saying you didn't like this one too much. But if you remember where it starts, you will probably get the rest of it. It starts with the denominator. And if you can just remember that, the rest of it will probably kind of like happen. Okay, so it starts with the denominator. It's the denominator times the derivative of the numerator, because it's a little similar to product rule, kind of. Denominator times derivative of the numerator, but then what? Subtract. So the order, like you can't mix this one up. Okay, minus the numerator times derivative of the denominator all over the denominator squared. I'm going to pause there and let you write it down, and then I want to point out a common mistake. Okay. Do you see how this is g? I'm going to call it g of x, but like the denominator. This is g of x, and do you see how we have a g of x here? Don't cancel those. What I always say is no cancellation without factorization. If you didn't factor it out, it doesn't cancel. Okay, so just leave it alone. So let's try the quotient rule. So you need quotient rule for this one because it's a fraction. So we're going to start with the denominator. And again, if you remember where it starts, you will probably get the rest of it because it's very similar to product. So denominator, what's the derivative of the numerator? 3 minus the numerator. And then derivative of the denominator is 2 over denominator squared. Now I do want us to clean this one up a little bit. Sometimes it's just a total disaster and there's really not much you can do. This one's actually going to simplify down kind of nice. We're going to distribute and combine like terms in the numerator. So it's just a bunch of algebra. If you distribute this 3 through there, that'll be 6x minus 3. I'm just going to write it right above to like save myself from having to copy the whole thing over here. Now, when you distribute over here, You're not distributing a 2, you're distributing a -2. So just because you want to subtract both of the terms. So it'll be minus 6x minus 14. And so the reason this one's actually worth doing, sometimes it's like you just have a mess. Nothing you do is going to make it look any better. But this one is actually going to simplify down nicely because what's going to happen? Yeah, those cancel. You'll just have -17 over that denominator squared. So my rule is kind of like, if you can actually improve the situation, please simplify it. And if there's nothing that can be done, then just walk away. So number 9, again, we know we need quotient rule because it's a fraction. This gets long horizontally. Start like way over here on the edge of the paper, because otherwise like it's going to run into question 10. Or I don't know how large or small you write, but start all the way over there. All right, so the denominator, 5x cubed minus x. Derivative of the numerator, that will be 2x minus 3. Minus the numerator. And then what would be the derivative of the denominator? 15, it's a 5x cubed, sorry. 15x squared. We wrote it right here. You can look back at this one. And I apologize, it is blurry. I'm sorry. I'm very sorry. Sorry. Okay, cool. I'll do better. 15x squared. And then this is a little tricky. It's -1. Good. And then over the denominator squared. That is one I would not really expect you to do anything with. You can distribute all that if you want. Does anyone want to? Yeah, I'm sorry. Did you start all the way at the edge? Oh, you mean if we kept going? Okay, gotcha. Okay, number 10. Again, we need quotient rule because it's a fraction. So it is the denominator times derivative of the numerator. So what's the derivative of the numerator? 1. This is personal preference. You can choose to write it or not. I usually say write it only because this is very much pattern driven. And if you leave off that part of the pattern, you might mess yourself up. So that's my 2 cents on that. All right, minus the numerator. You can flip back if you need to, but let's see if anybody remembers. You should just try to just know the derivative of square root, because otherwise you're going to have to mess with all those 1/2 and -1. Okay, 1/2 square root. Yeah, no, I know what you meant. 1/2 square root of x. If you just know that one, you are so much better off. Over the denominator squared, and that's actually kind of nice because if you do square root of x squared, it's just x. We are going to simplify this down a little bit because do you see how we have a fraction in a fraction? That's kind of like not good, okay? So we're going to multiply here. I'll use a different color. We're going to multiply the numerator by 2 square root of x, and that means we have to multiply the denominator by 2 square root of x as well. Now you're like, why is she making us do this? Because this is one, like on the AP exam, if it was multiple choice, they would probably keep going, and I wouldn't want you to not be able to pick your answer A, B, C, or D. So like, you'll be okay, I promise. So we're going to distribute this 2 square root of x to both parts. I promise it'll make it look nicer. Because when you multiply it here, square root of x times square root of x would just be x. So that'll just be 2x. And then the whole point of multiplying it to here is that these are going to cancel. So all you're left with is the x plus 5. I'm going to distribute the negative though, so it'll be minus x minus 5. Again, the whole idea was we wanted those to cancel, so there we go. And then over, now our denominator would just be this, 2x square root of x. And then what can I fix in the numerator? Or not fix, but like combine, I guess. Yeah, so it will just be x minus 5 over 2x square root of x. See, so it was kind of worth it because it does look better now than it did before. Now we're going to take what we just did and apply it to something for these next 3, for 11, 12, and 13, right? Find the, oh, I thrown some vocabulary at you. What does an instantaneous rate of change mean? It just means the derivative. Do you remember Alice going for a walk? I bring Alice up a lot because that's like an easy thing to relate it to. We're going to find the derivative of this at x equals 8. First, let's rewrite that function. And that's a cube root in the denominator. Okay, so I can rewrite that as 2x to the negative 1/3. Cube root means it's a 1/3. Why is it negative? Yeah, it's in the denominator. So we're going to do the derivative, and then we're going to plug in 8. Sometimes I'll write out my steps, like, okay, here's what I'm going to do. So I'm going to find the derivative, then I'm going to plug in 8. So derivative, you would multiply the negative 1/3 down, so negative 2/3. Extra tricky here. You have to subtract 1. Negative 1/3 minus 1. It would be negative 1 and 1/3. Negative 4/3. Good. And I'm going to rewrite that before I plug in the 8 because there's a lot of negatives and I would like to fix that. So usually what I'll do is draw a fraction bar and then decide what goes upstairs and what goes downstairs. So we've got that negative 2/3 that is just going to have to stay like that. X is going to go on the bottom because it's negative, and you want to write it as a root. Remember what I told you about how you know which number goes where. The root can't change from the original problem. So what kind of root is it? Cube root, and then underneath of it, x to the 4th. Or you could also write it like this, which is probably how I'll work through it when I plug in the number. That means the same thing. It doesn't matter if the 4th goes inside or outside, that 4th power. Because now we're going to plug in 8. And without a calculator, I don't know what 8 to the 4th is in my head, but I know cube root of 8. What's the cube root of 8? Get 2 to the 4th. Work it out. 2 times 2 times 2 times 2. Good. 16 times 3. 48. Negative 2 over 48. Oh, and that'll actually reduce. Negative 1 24th. Twelve is asking for a whole equation. There are 2 things you need for an equation. What are they? What do we need? Point and a slope. I always write them out blank just to like set it up. So the point is going to be negative 1 comma something. How do I get the something? Plug it in. Here's my advice. Do that before you get the derivative, because then you won't mess up where you're plugging it in. So if you plug in negative 1, let's see, that would be negative 6 over 4. So negative 3 over 2. Slope comes from derivative. Derivative means slope. What rule do we need for this one? Quotient. All right, denominator times derivative of the numerator, which is 6, minus numerator derivative of the denominator would be 6x over denominator squared. Here's my other piece of advice, because I get this all the time. Don't do anything to that. I get people that start doing all this algebra. Algebra is where you're going to make your mistakes. The calculus is actually easy. It's just write that. That's the calculus. The algebra is where everybody messes up. So don't do any algebra if you don't have to. All you have to do is plug in negative 1. That's it. And that will give us our slope. So let's see. If we plug in negative 1, this first part will be 4 times 6 be 24 minus, all right, now let's see. If we plug in negative 1, that's going to be negative 6 times negative 6, which will be 36. And then what will we have in the denominator? Was that 4 squared, so 16? So what is that, negative 12 over 16? Double check me, I'm doing this all in my head here. And so that'll be negative 3/4. That sounds right. So here's your point, here's your slope. All you have to do is put them together into an equation and then walk away. That's it. So assemble. It'll be y and then what? Plus 3 over 2, perfect, equals negative 3 over 4, parenthesis, Were there enough negatives in that problem for you? We'll do one more and then take another break. I know it's not super fun. You just have to practice all of them. All right. Find the fourth derivative. All right. You can't jump straight there. You have to do them in order. So what's the first derivative? Perfect. And do you remember how to denote a second derivative? It's just f, like, yeah, double prime. So that would be 36x plus 4. Third derivative would be 36. Now, when you get beyond that, we just put like the number there for fourth derivative, which would be what? 0. So your fifth derivative would be 0, and the sixth derivative and the seventh derivative, all of them will be 0. I like that too. It's nice. The only one I like better than that is e to the x, because every single derivative. Yeah, all right, so yes, this last one is chain rule. So power rule is for when you have an exponent. Product rule is when you're multiplying two functions. Quotient rule is when you're dividing two functions. Chain rule is for when you have a composite function. So f of g of x. This is like f got hungry and ate g. There's one function inside of another is when you need this. But do you remember it at all? Or what do you remember? I'm going to see. I'm going to tell you it, obviously. But... So it's derivative of which one? The outside or inside? Like the big one? Outside. So you do a derivative of the outside. So again, don't get hung up on f and g. In your brain, think of them as the outside and the inside. So it's derivative of the outside. You leave the inside alone. I call that the guts of the problem. Leave the guts alone. Literally just copy it. And then you chain on, so multiply on what? G, good, the derivative of the inside. That leaving the inside alone is the common in this part. Okay. Also, and knowing when to use it. So let's go ahead and look at a couple of these. The way I know I need chain rule, and chain rule usually gets coupled with the other rules as well. Like you'll need both chain and product rule sometimes. Do you see how you have this stuff in parentheses to the fifth? Like it's not just x to the fifth, it's blah, 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 blah to the fifth. If there's not just an x, if there's more stuff, that's the inside function. All right, so derivative is going to be bring the 5 down, because the fifth power is the outside function. This power rule is what we're doing first. Bring the 5 down, drop it to a fourth. The insides stay the same. So literally just copy them over. And I'll do it blank like that usually, just to kind of like set up the framework of it, and then you can go back and fill it in. Times, and now we're going to chain on the derivative of said inside stuff. So that would be 6x squared plus 4. You don't need to do anything to that. Actually, you can't distribute these together. Why not? Yeah, like this one's to the fourth and that one's not. So like you actually can't do anything. I guess you could distribute the 5 into this one, but like why? All right, we'll just move on. Now this one, you're gonna need a chain rule. What other rule are you gonna need though? Okay, I will color code. This is the first function. This is the second function. All right, so product rule first, and start over to the side. This one's going to be long horizontally. So it will be the first, which is x to the fourth, times derivative of the second. That's the one I underlined pink. That one's going to need a chain rule because it's not just x to the third, it's like stuff to the third. So we're going to bring the 3 down. It'll drop to a 2. Again, just draw it blank like that if that helps you. The insides stay the same, and then you chain on the derivative of that inside stuff, which would be what? 3. Good. So here, let me color code again. This is first times derivative of the second plus, and then what's going to come next? You're not wrong, but I have to do it in my order or I start to confuse. You're totally right. You do you. I have to do it in my order though, or I confuse myself. So first times derivative of the second plus the second And then times derivative of the third, which go ahead and say it again because you were totally right. 4x cubed, perfect. And what we want to do to clean this one up, I'm not going to distribute any of that together. What we want to do is factor it. And you're like, why is she making us do this? Because later when we get to the first derivative test and you have to set these equal to 0, do you remember derivative equals 0, find your critical points? You have to be able to factor them. So like, let's practice it now. Believe it or not, there's only 2 terms. This is all the first one and this is all the second one. So just look and see what they have in common. We're just going to do GCF. What have they both got? This one and this one. They both have some 3x plus 1s. So we have some of that and then one other thing that they've both got. I guess we can take out x cubed. You can take whatever the smaller one is, okay? So we're going to take out x cubed, and then how many of the 3x plus 1s can we take? Just 2 of them, just squared, right? That's your greatest common factor. A lot of times I'll put a bracket for the next part. A bracket is a parentheses big brother. It's just another grouping symbol. It means the exact same thing. And I'll also usually scribble out whatever I've taken because that helps you like see what's gone. So from this first term, if I take x cubed, I've only got one of them left. And I'm taking out the 3x plus 1 squared. So this is gone. So what's still there? I guess, like, what did I not scribble out? Yeah, 9x, because we had 3 times. Plus, and then if I scribble out over here, I took the x cubed, and I took 2 of these. So there's only 1 left. So let's distribute the 4. That would be what, 12x plus 4? I'll go ahead and stop there. The only other thing you could do is add 12x and 9x. I believe in my heart you could do that. So we'll go ahead and stop there. But the factoring is the important part because you have to be able to do that. All right, yes, this is going to be a chain rule. And then what rule? Quotient, good. Okay, chain rule first because we're going to deal with that power that's outside. So you bring the 2 down. It drops to a 1. You don't have to write the 1. I just sometimes do that so everyone can see that it did drop a degree. The inside stuff stays the same. I'll read it to you because I know it's a little blurry. X squared minus 8 over x plus 1. So that was the outside function. That was the squared. Now we're going to chain on the derivative of the inside, and that's a quotient rule. If you remember where it starts, you'll probably get the rest of it. So where does it start? Well, yeah, the denominator, right? Okay, so x plus 1. Derivative of the numerator would be 2x minus x squared minus 8, derivative of the numerator, times derivative of the denominator, which would just be 1. Again, I suggest writing it because this is very pattern driven, and that's part of the pattern. You don't have to. Again, it's like your preference. Over denominator squared. And I'm going to do one step of cleanup here because this is kind of a mess and we can make it better. If you can make it better, I usually say do that. Draw yourself a big old fraction bar. We just decide what goes upstairs and what goes downstairs. Where does this 2 out front go? Yeah, up, right? Because it's really 2 over 1. And then we've also got an x squared minus 8. And then this part, let's distribute and kind of put some stuff together. If you distribute that 2x, that'll be 2x squared plus 2x. If you distribute that minus, or I guess I should say negative, it would be negative x squared plus 8. So I just distributed there. So what can we put together? Let's see, that'll just be, yeah, x squared plus 2x plus 8. And then downstairs, it'll actually be x plus 1 cubed. Good, because we have one of them here and then another 2 there. So x plus 1 cubed. So do you see how it looks better? Again, if you can make things better, then you should try to, at least a little bit. This one's not, we're not really going to be able to make this one better. So yes, there's going to be a chain rule and a quotient rule. So it is denominator times derivative of the numerator, which would just be 1, minus numerator, and then derivative of the denominator. Maybe just watch me do this part. What's our derivative of just square root? Just square root of x, not this, just square root. It's 1/2 square root. So you will put 1/2. It's just instead of just x, it's like that stuff. It's still the same rule. 1/2 square root of whatever. Do you see how I did that? 1/2 square root of whatever. And then you have to chain on the derivative of the whatever. So what's the derivative of that inside stuff? 5. And I would just put it in the numerator. You can like write it off to the side, but I would just put it in the numerator. And that's all over denominator squared, which is actually kind of nice because the root will cancel just 5x plus 1. I'm not going to make us go any further here, but just for the sake of being thorough, where is it? Do you see how on this one we multiplied by that 2 square root of x and got that stuff to cancel? You could actually do the same thing here and multiply by 2 square root 5x plus 1. And some of that stuff would cancel and it would kind of break down. I'm not going to make us do that here, but like you could. Okay. But I know you guys are super having fun. All right. This one says equation. What do you need to write an equation? 2 things. Point and a slope. All right. So the point is going to be 1 something. Write it out blank. That'll help you remember what you need. Plug in the 1 right away to get the point before you even find the derivative, because then you won't mess up where you're plugging it in. Plug in 1. That would be 3 for that part. And then what would that be? 3 squared, so 27. All right. What rule do we need? Well, we need chain rule, but what other rule do we need for this product? The 3x is the first thing. The 4x minus 1 squared is the second thing. All right, let me see if you guys can tell me. Derivative, what's going to be first? 3x, good. And then when you do the derivative of this, you're going to bring the 2 down, drops to a 1. What do I put inside of there? 4x minus 1 stays the same, and then chain on 4. So first, derivative of the second, plus what comes next? Thank you. And then 3. Again, that order doesn't matter. It's just that's the way I've been doing it for years and years. So like I have to be consistent or I forget what I'm doing. Don't mess with that. Don't do algebra. Algebra is the enemy because it's where all the mistakes happen. Just plug in 1. So if we plug in 1, this will be 3. Let's see. This will be 2 times 3, so 6 times 4, 24. And then what will that be? 3 squared is 9 times 3 is 27. Three times 24, what is that, 72? 72? Plus 27, ooh, which that weirdly is 99. You get that that's the slope of the line, right? Up 99 over 1. And then you just write the answer. Y minus 27, the y part of your point, equals 99, parentheses, x minus 1. What mode should you be in? Radians. We're not going to do any trig right now, but it's worth mentioning. All right, so just go ahead and make sure you're in radian. We're going to just do this one on the calculator. You guys have been really good about practicing a lot. This is very much a drill and practice thing, and you guys have been awesome about it. So we're just going to do this one on the calculator. The calculator is an important skill. On the AP exam, on the multiple choice like calculator part, they will always throw you one of these, and it's a freebie. You just type it in the calculator and get the answer. Sometimes they do a couple of them, okay? What does instantaneous rate of change mean? Yep, derivative, slope, tangent line, perfect. We're gonna do the derivative of this at 7. It is math 8. Math 8 and math 9 are going to be your best friends. One is a derivative and the other is an integral. Do you remember doing math 9 last year? A ton. Integral from where? All right, everyone go to math 8. And you will literally just type what's there. All right, you're going to do d dx. Put the function in those parentheses. What does that bar mean? Or did you guys not talk about that last year? That's fine if you didn't. It means such that. It's a such that bar. Such that x equals 7. So the calculator's cool. I will say this though, if you type one thing wrong, it won't give you the right answer. So you got to be really extra careful. So when we're practicing calculator stuff, make sure you practice. Don't just watch and go, yeah, I could do that, because it's a skill that you need to have. How many decimal points do you also have to have? And it's the first 3 that you see. Truncate, don't bother rounding. I don't know how to explain this to you, but if you only put 2, they will literally not give you the points. Like you don't get any negative points in the AP exam. You either earn a point or fail to earn a point. You will fail to earn the point. What'd y'all get? Moment of truth. Before I hit enter on mine. Oh, is it a really big number? Oh, whoops. Oh, cool. All right, 856,829.851, which is a great answer. Don't discriminate. But math 8, you just put in the function such that whatever number you want it at. So your calculator won't find a derivative, but it'll find a derivative at a specific value. And then these are my absolute favorite, because there's no algebra. This is pure calculus with no algebra, okay? What rule is this asking for? Here's the only thing anyone ever gives me a hard time on. They don't want to write the rule. They won't give you credit on the AP exam unless you write the rule. So just do it, okay? It is first times derivative of the second plus second times derivative of the first. I know you're like, we already wrote that on our sheet. I get it. Do it again. Then plug in the numbers and don't simplify it. If you do it wrong in your head, it will be wrong. Like, you literally have to do nothing except be able to read a chart, which sometimes can be tough. So just make sure you're careful. We are plugging in 4. F of 4. You guys can shout them out to me. We'll just make sure we can read the chart. 2. Perfect. G prime of 4, negative 3, plus G of 4, 5, and F prime of 4, 8. Do nothing to that. But Miss Cole, I don't care. Leave it alone. It's easier for me to grade, honestly, if you leave it like that, because I can just look for all the numbers. All right, this is quotient rule. Write it out. You have to on the AP exam. When they give you these, they give you a point for writing the rule and then a point for your answer. Oh, and I just remembered this. Remember how we had those conversations about equal signs and how you should just try to write as few equal signs as possible? So do you see how on this one I didn't have an equal sign? I just went down to the next line. See how this one took up so much room? It's really tempting to go equals and then put your answer. They will not give you the point. That's considered a linkage error. This is the rule. And then the other thing is your answer. Don't link them together. Just leave a space and then put your answer. Just don't write any equal signs up. They would maybe give you a point for the answer. They will not give you the other point. They're usually worth 2. And I don't want you to miss these easy ones, all right? 6, G of 6. 3, F prime of 6, 1 minus F of 6 is 4, G prime of 6, 6 over 3 squared. What do you do to that? Nothing. And then I put 2 on here that are chain rule, because sometimes they'll do it backwards. And also chain rule is a little harder to read the chart on, so I want to make sure you're good. All right, this would be F prime G of X, leave the guts of it alone, chain on derivative of the inside. I'm going to zoom back out so we can see the chart. Maybe watch me point to this one because I think you're probably fine on those. Chain rule can be a little tougher, so just watch me point to it. We're plugging in 4. You have to start with the inside, G of 4. What is G of 4? Do you see that? 5. This part's 5. You now have to do F prime of 5. Do you see what I'm saying there? Okay. So what is F prime of 5? Negative 10. All right, so this first part's negative 10. And then we're doing G prime of 4, which is negative 3. That's a little tricky. We're going to do one more. I also did this one backwards because they do that on the AP exam where they'll use completely different letters. That's why I say don't get caught up on the letters. Outside and inside. Derivative of the outside, leave the inside alone. So in this case, that's G prime of F, and then chain on F prime. So again, here I'll point to this. We're plugging in 6. F of 6, looking at your chart, what's F of 6? 4. So this part I just circled is 4. You need to do G prime of 4, which is negative 3. And then F prime of 6 is 1.